Welcome to Wings of Arrow Advanced Education and Research Organization. To know more, visit our official webpage www.wingsofarrow.in. Find your dream aviation and aerospace jobs at www.wingsofarrow.in/jobs.
Now we are going to learn how to find the shaft speed for a liquid oxygen turbopump. Consider a liquid oxygen turbopump. Determine the shaft speed for a liquid oxygen pump which delivers 500 pound-meter per second of propellant at a discharge pressure of 1000 pounds per square inch and a suction pressure of 14.7 pounds per square inch. The oxygen tank is pressurized to 35 pounds per square inch. Neglect friction in the suction pipe and any suction head changes due to acceleration and propellant consumption. The initial tank level is 15 feet above the pump suction inlet. The tank head is 70.8 feet. Assume a suction specific speed of 15,000. Given data. Here, the mass flow rate m dot is equal to 500 pound-meter per second and discharge pressure P suffix D is equal to 1000 pounds per square inch and suction pressure P suffix S is equal to 14.7 pounds per square inch and oxygen tank is pressurized to P naught, which is 35 pounds per square inch. And suction specific speed S is equal to 15,000 revolutions per minute. Now we have to find out the shaft speed of liquid oxygen pump. The suction specific speed S depends on the quality of design and the specific speed. Then write S is equal to 21.2 N into square root of Q divided by HS suffix R to the power 3 divided by 4, where Q is the volume flow rate, S is the suction specific speed, and HS suffix R is the required suction head, and N is the shaft power. From this we can solve for N. First find volume flow rate Q and required suction head HS suffix R, and then we can find out the shaft power. When the mass flow rate is known and the density of the liquid can be assumed constant, this is an easy way to get Q. Then write Q is equal to m dot divided by rho. The density of liquid oxygen rho is 71.2 pound-meter per foot cube at its boiling point. Then Q is equal to 7.022 foot cube per second. And in this formula, HS suffix R is the required suction head, which is the limit value of the head at the pump inlet. Below this value cavitation in the impeller may occur. The absolute head value is the sum of tank head and the vapor pressure. We know tank head, which is given, and the vapor pressure of the oxygen is also given, which is suction pressure 14.7 pounds per square inch or 29.8 foot. Then the absolute head value HS suffix A is equal to 100.6 foot. The required suction head will be taken as 80% of the available suction head in order to provide a margin of safety for cavitation. Then HS suffix R is equal to 80.48 foot. Here we assume a suction specific speed of 15,000, a reasonable value if no test data are available. Now substitute suction specific value as volume flow rate Q and the suction head values in equation number 1 and solve. We get the required shaft speed N is equal to 7174 revolutions per minute. Did you know it weighs 780 tons? Though the Ariane 5 is only around 5 stories high, about twice the height of Buckingham Palace, but smaller than Big Ben or the London Eye, it packs a lot of weight. Well, mass specifically. It has a mass of 780 tons. That's roughly 61 London buses or 390 adult male elephants. Its payload is a maximum of 10 metric tons. This is what it carries when heading to geostationary transfer orbit. That means the cargo only comprises about 1% of the rocket's total weight. For this launch, the Ariane 5's payload is a new satellite for the European Aviation Network. A rocket launch is basically a controlled explosion. When the Ariane 5 lifts off, it will need 1,340 tons of thrust to do so. Tons of burning fuel inside the rocket supply that thrust. It's an explosion that generates a huge amount of force with very narrow margins for error. Rocket launchers merely channel and control those forces.
If you have further inquiry or requested video, drop down to our mail wingsofarrow@gmail.com. Don't forget to subscribe for more updates. For the time being, take care, stay blessed, inspired and fly high.